Hi, I'm Bob German, Cloud Developer Advocate for Microsoft, and I'm thrilled to be speaking at the very first PnP Virtual Conference. Thanks for joining the session. The topic is calling Microsoft Graph from your Teams application. We'll begin with an overview of the Microsoft Graph and Teams and kind of the place where they come together, and then we'll discuss 3 different ways to call the graph from a Teams tab and how to call it from a Teams bot, and then get into some resources. Now, I'm going to assume that you already know how to build a Teams application and how to call a RESTful web service. If not, you should still be able to follow the talk, but you'll have more to learn before you can put it into action. So let's dig in. So you're probably already familiar with the Microsoft Graph. You can think of it as the universal API for Microsoft 365. In and of itself, the graph is simple. It's a bunch of REST calls, but it's built on some complexity. OData is a little bit complex. That's the standard REST convention for doing create, read, update, and delete operations against collections of data. And it's great that the graph is consistent with that, so it works with various tools and is just familiar across all the different workloads. The other complexity, and the greater of the two for sure, is Azure AD. Every graph call requires an Azure AD access token to prove that the application and the user have permission to do whatever your graph call is asking. So that really is the main topic of today's talk, is how to deal with Azure AD and Teams to get that access token and call the graph. Now, your Teams app is probably going to call the graph. Most of the apps I've worked on end up sooner or later wanting to call the graph to interrogate information about the user, about the team structure, maybe to do something or access some content that the user has, even to add relevance and intelligence by, say, pulling up a list of recent documents or relevant documents to a user and that kind of thing. It's all in the graph, but you need permission and you need that access token in order to call it. You can think of Teams and Graph as being siblings, really. Teams being a user interface that exposes services across all of Microsoft 365. And so regardless if you're in the Teams desktop client, the web, iOS, or Android version, you're really pulling in data from Teams services, SharePoint files, and web pages, and just the whole list here. Every one of them comes right into Teams. And the Graph API is similar, except for instead of the user interface, it's the API for all of those services. So if I want to access, say, your notes in OneNote or your files in OneDrive, I'm going to use the Graph. Now, some of these services still have native APIs, and there are cases where you have to use the native API because something isn't yet supported in the Graph, but in most cases you can and should use the Graph API. Now recall that your Teams app does not actually run in Teams. It actually runs alongside of Teams, and it plugs into the Teams user interface through a file called manifest.json. For instance, a tab is just a web page. You could host it anywhere you want. All you have to do is put the URL in manifest.json so that Teams can get there. Bots and messaging extensions are just web services, and the manifest has the URLs of those as well. So now when your web page or your web service wants some information about the Teams or about anything in Microsoft 365, it needs to call the Graph API. There's no little shortcut through the Teams, through Microsoft Teams to get to all that information. You're going to go through the Graph pretty much. There's a little bit of glue, and we'll look at a little bit of it, that you need to kind of connect into the client. But 99% of the time, you're going to be calling the Graph. The complexity, of course, is that you have to include that access token from Azure AD. So in order to explain this better, let's take a step back and look at kind of the old school permission scheme that most operating systems have. In fact, the computer in your laptop bag or on your desk probably still supports this old model. Applications are just files in the file system. Users can run any application they want, and the applications run with that user's permission. The problem with this approach is that the user has no way of knowing exactly what the application is doing. So for instance, while this user plays a fun game, the application could be reading all her contacts and sending them spam emails. Now, we'd rather that didn't happen, but in an older operating system, there might not be an easy way to prevent it. A better permission model is found in some of the more modern operating systems, such as all the phone operating systems and mobile operating systems. Azure AD works that way too. Windows Store applications work that way. Applications need to be registered with the system just like users. Applications need permissions just like users to access specific resources. And then the users or their admins have to consent to give those permissions to the application. I have a screenshot here in the bottom right. Whenever I go to play Civilization Revolution 2 on my Android device, it wants to read my contacts. I always say no. I don't know what it would do if I said yes, but it really has no business reading my contacts since all I want to do is play this game. So the operating system is saving me here from who knows what that application wanted to do with my contacts. And actually it works fine even if you say no. So sometimes you really want to read those prompts, right? So Azure AD provides that same kind of permission structure. So how does that really manifest here? Well, in order to call the graph, you have to register your application in Azure AD. That's different from the application in your manifest .json that you give to Teams. You need to register an application in Azure AD, and it could be in either your tenant or your customer's tenant. In other words, you could put it directly where the users are, or you could put it in some other tenant. Maybe you're a product company, and you put it in your tenant, and then hundreds or thousands of customers refer to it from their tenant and use it in their tenant. That's either way that works. Then you need to specify the permissions that your app needs to call specific resources, such as the Microsoft Graph. So maybe you need group.read.all in the Microsoft Graph, which would allow you to read everything in the Microsoft 365 groups in that tenant. And I'll get into that a little bit more in the next slide. There are two ways to do this. One is ahead of time in the Azure portal, and that works with any Azure AD application. Some Azure AD applications can also do something called dynamic consent, meaning that they can actually ask for more permission after the application is running. And this is actually a very nice model, and it's available with the newer version 2 endpoint in Azure AD and certain OAuth flows. So it's not always there, but it is good to have it when you need it. And I'll point out as we go through the different options here where it's available and where it's not. Your app then can request an access token from Azure AD. This uses a flow, which is a protocol, not a automation product. Auth 2.0 flow is a protocol that gets the access token from Azure AD. And then Azure AD actually interacts directly with the user to authenticate them and prompt them for consent if needed. This allows Azure AD to do things like conditional access policies on multi-factor authentication, or to make the authentication seamless if it's appropriate. Azure AD can do all that because it's interacting directly with the user, and your application doesn't have to handle the user's password, which is another good thing about this system. If successful, Azure AD returns an access token to your app, which is good for about an hour. Your app then passes that access token to Graph in the HTTP headers to do whatever it is that it needs to do. So really now we have two kinds of permission. We have the application's permissions and the user's permissions. So how do they work together? Well, the first method is delegated permissions. This gives the application access on behalf of a user who's logged in. So for instance, if Alice has access to SharePoint sites 1 and 2, and the app has files.read permission, then when it's running as Alice, the application will be able to read only the files in SharePoint sites 1 and 2. On the other hand, app permissions are carte blanche. They give the application access to everything in the tenant. So files.read would mean any file in the tenant. So app permissions are useful for background processing and daemon applications, and also to elevate permissions. but it's a lot of responsibility to have, and they should be used sparingly. Now, these are the different authorization flows, the different protocols available, and I'm not going to talk too much about them, but I'll be referring to them during the scenarios that follow. Some of them only work from a web browser. Others work from a native application. Notice that client credentials flow is the only one that gives you an app permission. Everything else is delegated user permissions, and there's no way to do an elevation inside of a client device or a web browser. You really have to do that from a service somewhere. So we're mainly going to be talking about the user permissions in this talk. So let's just quickly have a look inside of Azure Active Directory. I'm going to be going through a number of different scenarios, but all of the scenarios have app registrations here under app registrations in the Azure AD portal. Sometimes I have to go to all applications even to find some of my applications, so I'm not sure why that is, but you might need to do that. And this is where you would come in and register your app, get the app ID or the client ID, which is the same thing. Your tenant ID is here. This is where you define the rules for authentication, which are different for each of the scenarios, and also the API permissions. So here I'm getting the graph permission, user delegated. You can see that clearly. I'm getting permission to read the user's email and to read information about the user. So basically all my scenarios, I'm just going to read the user's first few emails as my demo. So they're all kind of set up like this. And then enterprise applications is where the customers would manage their end of the deal. So here's enterprise applications. These are also called service principals, which can be just a little bit confusing. But these are all the service principals. What happens is when a user or an admin consents to give the application permission, that gets stored here in the tenant where the customer is. So let's say I want to see what users have actually granted consents. I can come in here and get all that information. I can also delete this thing if I want to kind of reset and delete all those consents. So everybody will just be asked to consent again if I delete this. That's really useful during testing. All right, so let's dig into some real scenarios here. I'm going to show you 3 ways to get a graph access token from a Teams tab. And recall that your Teams tab is just a website hosted anywhere on the internet, and Teams is going to stitch that in to the UI using an iframe. So the first option, and probably the best option in many cases, is going to be to use Azure AD SSO. So this is a new single sign-on feature in Teams that was just generally available at Build 2020. So pretty new as I'm recording this anyway. This gives the best user experience, no prompting, no pop-ups. It works in multi-tenant apps, so if you're an ISV and you want to register the app in your tenant and then have customers consent to your app in their tenant, that's possible here. It does, however, require a custom web service, so you're not going to have a completely static website for this. And right now your website, you can only have one domain per app. So suppose you had 2 tabs in your app and you wanted one to be hosted at contoso.com and the other at fabricam.com. Well, you can't do that here. And also azurewebsites.net hosted apps are not currently allowed. I think that may change, however. So this is a great method, probably the best user experience, also probably the most complex one to implement. The tooling is getting better and will make it a little bit easier. So I'll show you that first. And then SharePoint Framework is a great option. It has that same great user experience of the user not getting prompted. And actually, that's because it runs on top of the Azure AD SSO feature. So you also get easy SharePoint hosting. So if you wanted to host it somewhere else, then this isn't the option for you. But if you are open to having the customer's SharePoint site host your web page, this is a great option. Of course, it's not going to really work for cross-tenant. The admin has to consent, so that's potentially a downside. Even if you need very small amount of permission, the user can't do it on their own. And this is a caveat that I think is going to change, but right now I think it could be certainly something to note, is that the permissions you give your app are shared by all third-party web parts in the tenant. I don't, there's a thing called isolated web parts that solves this problem, but isolated web parts do not currently work with Teams tabs. I'm not sure why they made that choice, because frankly, the Teams tabs are only one web part on a page anyway. So the idea of a shared access token is really kind of lost here. But for whatever reason, right now, if you had an app that needed, say, files.read.all, the admin in the process of granting that to your app is going to be giving every third-party web part in the tenant files.read.all access. The third, and this is the original option that's been around since the very beginning of Teams, is to write a pop-up login page. So why a pop-up? Well, most browser-based authorization schemes do not work in an iframe for security reasons. So all this is a very simple little mechanism inside of Teams that launches a pop-up and then allows the pop-up to send a message back to your application. And you can put anything in there you want. An Azure AD login is obviously what I will show, but this works with non-Azure AD. As long as you can log users in via a web browser, you can put whatever code into that pop-up you need to log the user in against any kind of auth scheme. This, of course, could also work with multi-tenant apps, and this works beautifully in a completely static website with no web service, which is what I will show. The user does, however, see more pop-ups, so that's kind of the downside. All right, so let's start with Azure AD SSO for tabs. When you look at this, it might seem like the simplest thing you can imagine, because all you have to do is call this get auth token function, and you get an auth token. That's the good news. The other news, however, is that auth token is extremely limited in its permission. If you wanted to do even a very basic thing like read the user's own profile, you need to implement a web service that exchanges that very weak token for a stronger token. And also, in order to support user consent, your UI has to be prepared to prompt the user. So maybe it's the first time the user came and used your app, and you're requesting a permission that they have not previously granted to your app, and the admin hasn't granted to your app. So you actually have to include extra code for that one case that will pop up a consent window from Azure AD. So that's why this is, although it's the smoothest for the user experience, it's actually the most complex, I think, right now from a developer experience. So now I'll show you the user experience, and it'll go fast. Okay, that's it. So it just got the token from getAuthToken, exchanged that in my own web service for a more privileged token that has mail.read, and then I called the Graph API with the mail.read token and read the mail. The nice thing is if I leave the tab and go back, it's just as fast every time. And if I pop over to a mobile client, you'll see that the experience works just as seamlessly there. And I think this is especially important in mobile, where users really don't want to be prompted and trying to type their password and stuff on their phone. All right, so a quick flyover of the code. First, going to get the auth token from Teams using this get auth token call. Couldn't be simpler. Then I'm going to exchange that. So I'm going to take that client-side token and send it to my own endpoint /auth/token. And I'm going to get back a server-side token. And I'll show you that code in just a sec. Then I'm going to use that server-side token to call the graph. In order to do that exchange, here's the server side. I'm going to build up this request for Azure AD. No libraries here. It's just direct REST call to Azure AD. And then I'm going to fetch and hopefully get back the elevated token. But there is the possibility that I could get an invalid grant or an interaction required error here, and I should really be checking for just those errors. And this will trigger the pop-up to request consent and then try the whole thing again after the user has had a chance to consent to the elevated permissions the first time. Next up is SharePoint Framework, and this is really a nice scenario because you're actually writing a SharePoint Framework web part, which could also be something you had already maybe built for SharePoint. So the key here is to include in your SharePoint app manifest the permissions that you need. And then an admin has to go and grant those permissions. I have a screenshot over here. It's actually in the SharePoint admin and rather than Azure AD that happens. And then the beauty of it is that SharePoint Framework just handles all the security for you. All you have to do is use the MS Graph Client Factory, and it gives you a client that's already loaded with all of the authorization code that you need. So you just make your call. It's really a beautiful thing. You can also call your own Azure AD protected services or anything other than Graph using the AAD HTTP client object, and SharePoint Framework will fill in the security part for that too. So let's see how that works. Again, this is a really quick demo. That was it, right? The tab just comes right up, and if I click on it again, it comes right up again. And the mobile client, I think they just recently added support for this. Mobile client works great too. So this is a great option as long as you're happy to use the SharePoint Framework toolchain and to host in SharePoint. So the third option that I'll show is to use a pop-up window. This is extremely flexible because you really could put anything you want inside of the pop-up. So if you look at the diagram, you can see the white box on the left is where your single page app is running in an iframe. You have some JavaScript there. You call the Teams Client SDK. It launches a pop-up window. You can put any code you want in there to get any information you want or do whatever you kind of want and pass back. Usually it's the access token. In my case, I'll also pass back the expiration date and the username to the hosting application, and this just uses the interframe messaging, which has to be supported by the hosting application of Microsoft Teams. So you just make this call to authentication.authenticate, which ironically doesn't actually authenticate anyone. It just launches the pop-up, and then your pop-up can pass information back using the notify success or notify failure call. So let's see what this looks like from a user perspective. All right, so I'm going to click the button, and you see the pop-up, and okay, that wasn't too bad. I didn't actually have to log into the pop-up because Azure AD had already left a cookie in under its own URL in the browser and was able to just sort of say, oh, he's already logged in, right? But it could have logged me in. It could have done multi-factor authentication. It could have done some user consents. It basically, Azure AD could kind of work with me for a while to get everything it needed. In this case, there was nothing, and it was very quick. The thing is, if I leave the tab and go back to it, I'm starting over again, right? I have to go through, and I'm going to see that pop up again. Why is that? Well, it's because really this is a new browser view, right? Like when I left the tab, Teams doesn't keep all your tabs kind of alive in suspended animation somehow. It doesn't just hide them the way a web browser would. The tab, it's an iframe. It's gone when you leave the tab in the Teams UI. So now when you come back, you have to reestablish and get that access token again. So if I go into the mobile client, you'll see that it works there too. And I am going to see that auth experience real quick. Okay. And then it's actually going to work. So to do this, I actually had to write a separate web page that didn't use the Teams SDK, that just used the MSAL client that I'm using to get my access token directly on the page. I'm told that this will be, I believe it's on the roadmap to put full tab support into the mobile clients. But right now, in this case, the pop-up doesn't work, and so you have to write a separate web page. So I built this application using the new Visual Studio Code Teams Toolkit. extension, which was a great experience. And you'll find if you create a tab, what it does is it uses the Create React generator from Facebook to make a very clean and simple JavaScript application. So this is the main React component. And whenever this runs, it's actually going to call my init function. And it exists because at certain points in the sequence, Azure AD is going to interact with the user in either the Teams pop-up, which is my web page, or in my mobile web page. It's going to interact with the user and then send an auth code back, which I can exchange for an access token. Now, this auth code is actually new. This came out MSAL 2.0 with auth code PKCE flow for browsers. Just came out at build and is a more secure method than the implicit flow that we had previously used. So that's what I'm doing here. And but I do have to check every time a page comes in, hey, is this the thing that has that auth code in it? So I'm going to this init function is just going to call the MSAL client and give it a chance to handle any redirect that might be there. And then I'll gather the username from either the response or from the MSAL cache and or object, and I'm off to the races, right? So after that's done, I can check and see, I'll set a state variable so that I can see that I've done that at least once, and now I'm going to route my request out to the various virtual pages in this little single page app. Notice I have one for tabs, one for the web, the standalone web, and I have this Teams auth pop-up that is going to handle the pop-up page. So when that pop-up page runs, when the Teams tab wants to log the user in, it's going to call this function, which to get the access token. Again, I wrote this, but it just calls that Teams authenticate call that doesn't authenticate, right, to launch the pop-up. And you can see here's the path to my own pop-up, right? And then I'm going to get back the username access token and the expiration on that and maintain that in a singleton where I can sort of only go back and do this when the expires on has been passed, right? When that time has been passed. Now, then I'm not going to walk through all the code in the pop-up or in the standalone browser. You can download all of it, but I will show you that basically they're just calling login, which does a login redirect. So this is the other end. I'm trying to log the user in. I'm going to redirect over to over to Azure AD and let it interact with the user. And then later I'll get that redirect back that I showed you a minute ago, right? And then when I'm ready to get the access token, hopefully I can just get it so-called silently, meaning that MSAL has already got it in memory. And if that doesn't work, I'm instead going to do a redirect on line 113 back to Azure AD to let it interact with the user and get the necessary permission. I'm going to close with a bot scenario. The user delegated choice is to use the Auth dialog. So this is a dialog inside the bot framework that can pop up and authenticate the user. I'm not going to have a lot of time to get into the details because bots are a big topic, but let me just show you what it looks like to the user. So if I go in and talk to the bot, it's going to give me a sign-in button. So this is the auth dialog in the bot. And again, I get sent to a web browser. It really works better if it's in a web browser because then Azure AD can interact directly with the user through the browser. And then all I have to do is click the button to get my mail. The nice thing about this is that the bot framework stores what's called a refresh token behind the scenes, so that if I come back later, or even if I come back on a different device, I'm already logged in. I don't really need to do that any more often than the life of the refresh token, which I think is 6 months or something. So that works really nicely. So here's my troubleshooting checklist really quickly. Always test in Postman. Check all your IDs and secrets. Check the admin consents. I'll let you read this on your own. And But sometimes it can be a little frustrating because you get just like a 401 access denied. It can be a little tricky to figure out what happened. So I recommend these steps. Here is the resources, and you can see here there's a companion blog article that should cover most everything that's in the talk and maybe go a little bit deeper. And then all of the demos that I've showed, including an additional one, which is the Graph Toolkit option, which basically wraps around scenario number 3 right now, but for the tabs, but it could change in the future because everything is packaged up into these beautiful little web components. My teammate Aicha Bosch has actually written a great article and walkthrough on that and demo, so I'll point you to that. And I'm also putting in a plug for Teams samples. So as part of the PnP community, I'm actually gathering and curating Teams application samples. So I would love your pull request. Please check out the sample browser and see what's there across both the community and Microsoft. And then do a pull request and let us have your samples as well. There's also some great videos up there on the PnP channel. So thank you so much for joining. We do want your feedback. So please use this QR code or the URL to provide feedback if you like the session. And thank you so much. Sharing is caring. It's a real pleasure to be part of the PnP conference.